Hello everyone, welcome to your third lesson in Python. My name is Tyler and I will be subbing in for Jan today. For a little background, I am a senior computer engineering student at UCF. Today we're going to take a look into conditional statements, logic operators, and equality. At the end we will combine these concepts in a function and watch it all play out. So let's get started. Can you move forward in life without making decisions? The answer is no. Programs are the same way. They need to be able to make decisions in order to generate results and solve problems. Conditional statements allow programs to make decisions on what to do next. We will learn about conditional statements such as if else, and the if-else ladder. So the if statement is pretty straightforward. If you have a condition and it is met, perform the block of code. So let's look at a quick example of this on a code editor. We'll pull one up. We already have here that we're getting input from the user. We want a student's grade. And now the program will process what that input is. So if convert the string to an int, if a is greater than 50, don't forget the colon. We want the user to know that the student passed. So we'll say print pass. We'll save that and we'll run that. So our program is going to ask for the student's grade. We're going to say 51, and we're going to see that the student passed. So that's a very basic example of processing with an if statement. The next conditional statement we're going to look at is the if-else statement. If the condition is true, process the block of code. Otherwise, process this block of code. So if we go back to our example, if the user enters any number less than 50, there would be no output. The program would just end. Let's try it out. If we put in the student's grade as 49, the program just ends. So with an else statement, we can now say, okay, if it's greater than 50, print pass. For any other case, print failed. So now when we run that same example, and we write 49, we're going to get failed. The next conditional statement we can go over is the if-else ladder. So if we have a condition, perform the block of code for if it's true, but instead of just saying otherwise, have a block of code for every other condition, we can have a second if statement. So if the first if statement isn't true, we can check the second if statement. Is that true? If so, perform that block of code. Otherwise, perform the else statement for all other blocks of code. So let's take a look at this in the example that we have. Let's say that if they got greater than a 45, we're going to let them know that they were close to failing, but they still passed. So in that case, we could say else if the user input was greater than 45, tell the user that they were close to failing, but we let them slide. They're still going to pass the class. So let's go ahead and test that out. Let's say the user got a 46. So they were close to failing, they didn't fail. Let's test out some other numbers to make sure that this ladder works. Say the student got a 51. They passed. Let's say they got a 44 and they failed. Another way to test if a condition is true is through relational operators. Relational operators compare one value to another and determine the truth of the statement. The truth of relations is often used to make decisions in programs. They ensure a condition is met before performing a specific task. I've excluded less than or greater than in this table because we've already seen them in previous examples, but they are considered relational operators. Let's take a look at some of these new ones. The first one, the double equal sign, determines whether the two values, one on the left of the double equals and one on the right of the double equals, are equal. We can see in our example, 1 definitely isn't equal to 2, therefore the output will be false. The second relational operator is not equal. And this determines if whatever's on the left of the operand is not equal to whatever's on the right. So we have here in our example that 1 does not equal to 2, and this is obviously true. Our third operator is greater than or equal to. This verifies that whatever is on the left of the operand is greater than or equal to whatever's on the right. Our example is 1 is greater than or equal to 2, and this is obviously false as 1 is less than 2, so the result will print false. Our last operand is less than or equal to, and this verifies that whatever's on the left of the operand is less than whatever's on the right of the operand. And we know that 1 is less than or equal to 2, and so the result is true. These might seem rudimentary, but they're used throughout this entire course, and they're used anytime you're going to be making a decision in your programming. One thing I'd like to make a note of is you always want to test things out. Don't just take my word for it. Always see for yourself what the result is going to be. So what we can do here is we can pull up our code and we can print the result of some of these statements. So let's say print 1 equals 2. We know that this should say false, but let's run it. The result is indeed false. So let's go ahead and run all of these and see if the results match what we have in the slides. So let's run that. And our result is false, true, false, true. And if we go back to our slides, we indeed have false, true, false, true. This is a practice that you want to be taking, especially when you're debugging your code. Never trust that you know the output. Always run it and verify. We may also use these relational operators on other data types, such as strings. Let's put together a quick example. If the string WAP is equal to work and performance, print true. Otherwise, print false. And before I even run this, I forgot the colon. Let me put that in. And before I even run this, let's try to guess what the output's going to be. We know it's going to be false because WAP is only equal to WAP. We've now seen arithmetic operators, relational operators. Let's take a look at logical operators. In many cases, the execution of a block of code depends on the truth value of more than one statement. To accomplish this, we will learn about the AND operator and the OR operator. We will start with the AND operator. The way this works is that we have two inputs and one output. For the AND operator, both inputs need to be true in order for the output to be true. If either the input A is false or the input B is false, the output will be false. So here in case 1, A is true and B is true, therefore A and B is true. In case 2, A is true, but B is false. Since B is false, the output is false. We're going to flip that for case 3, where A is false, but B is true. In this case, the output will be false as A is false. And then in case 4, A and B are both false and the output will be false. The way this looks like in code, we will have a test condition, the first one on the left of the and then the second test condition on the right of the and. This will generate an output of either true or false if both conditions are true, or one of them is false, or both of them are false. So let's look at some of these examples. If 3 is equal to 2, and 1 is equal to 1, well, 3 isn't equal to 2, so we have false on the left and true on the right, and we know that to be false. For the second case, we have 4 times 2 is greater than 1, that's true, and we have 10 is less than 100, that's true. So the left is true and the right is true, therefore the output will be true. For the third case, 1 does not equal 2, that's true, and 3 is less than 1, which is false. So since we have false on the right and true on the left, the outcome will be false. In the fourth case, 1 equals 0 and 2 equals 1. Since the program read 1 equals 0 and it knows that's false, it's not even going to look at if 2 is equal to 1. It ignores that, the case is broken, and the output will be false instantly. The next operator we will look at is the OR operator. The way this works is that if the input A or the input B is true, then the result will be true. So we're going to go through the same cases here as we did with the AND truth table. If both are true, the result will be true. If only A is true, the result will be true. If only B is true, the result will be true. And if both inputs are false, the result will be false. This will look very similar in code to the previous example. We're going to have a condition 1, then OR, and then a condition 2. If either condition 1 or condition 2 are correct, we will get a true. If both conditions are false, we will get a false. So if we look at the same examples, we have 3 equals to 2, which is false, but 1 is equal to 1, so that is true. 4 times 2 is greater than 1, that is true. And just like with the AND symbol, if one of them is true, we don't even have to look at the second condition. We already know this will accept as true. But just for the sake of being complete, 10 is less than 100, we'll have true on the left and on the right. 1 is not equal to 2, that's true, and the statement is true. 1 is equal to 0, that's false, or 2 is equal to 1, they're both false, and the result will be false. And like I said before, just make it a habit of running some of these examples in code. I'm going to pull up the same code from before and just change the ANDs to OR. Clear it and run it. And we're going to get true, 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 false. And if we go back to our slides, that's exactly what we see here. For the rest of this lesson, we're going to first teach you something that will be used on your first homework assignment, which is determining the types of variables. And then we will create a function which puts some of the operators that we've learned into play. So the first slide here is identifying data types by using type. So sometimes we want to determine if we have an integer or a float or a string, and this can be done by using the function type on a variable. And in this example, we have a variable 3.14. We know this to be a float automatically because it has a decimal point, but we're going to print out to the console what the type of the variable is. The result will be class float. Let's go ahead and run this and give it a try. I'm just clearing our previous example. Alright, so we have my variable equals 3.14, and we want to print the type of my variable. Let's go ahead and run that, and we get class float. It checks out. Just for kicks here, I'm going to do an integer and a string. Print that and run that. So we're going to assume before we even run this that we're going to see float, integer, and string. And let's see what the result will be. Float, int, and string. In this slide, we're going to use type in conjunction with the if, else if ladder that we learned at the start. So let's run through the code real quick before we go ahead and code this up. We're going to be making a function that takes a parameter of any variable. We call it mystery variable. And if the type of mystery variable is int, print integer. Else if the type of mystery variable is float, print float. Otherwise, print error, mystery variable is not a numerical data type. So let's go ahead and code this up and play with it a little. We'll send through an int, a float, and a string. So we're going to define the function as num data type identity. It's going to take in a mystery variable. If type mystery variable equals int, print integer. If it equals float, print float. Else, let the user know that we don't know what kind of variable this is. And then we'll have our return statement to finish up our function. And let's see if this code compiles. Alright, so the compiler is not noticing any errors. So let's go ahead and run this a few times. Let's put in the same float from before. Oh, I can't type today. Let's put in an integer, and let's put in a string. So we'll go ahead and run this, and we expect to see float, integer, and then the error pop up. So hopefully that's what happens. So right away we can see we got float, integer, but then we got two errors, but we only sent string in once. So right away there's a problem within the code, and I'm sure some of you saw it as we were going along. But this is a valuable lesson because the compiler said everything's good to go, you have no problems in your code. But I made an error that was a logic error. The compiler won't notice that it is an error because it's not looking for logic. It's just looking to see, did you write something correct or not? So I forgot to say else if here. So what happened here is that we're first sending through a float. And because this isn't an else if, it's going to read this if statement first, say, okay, we're not an integer, let's pass through, and then it's going to say, we are a float, print float, and it won't get to this else statement, and it will return. Then the integer comes in, it comes through here and says, if I'm an int, print integer, okay. If the mystery variable is a float, print float, otherwise print error. And since the int isn't a float, it went to error. And then the string went through, it isn't an int, it isn't a float, so print error. So the fix here is to make sure to write else if, and this way all three of these blocks are intertwined. So if we go ahead and run this again, we should get the right output. And everything looks good.